This is a 16-foot 300 LED strip purchased from Amazon for $12.50. These are super white LEDs. Amazon also has warm whites and other colors. They use 8mm film reels for them. One end has an odd connector on it. Using that end, typically cut it off and strip the two wires out. The other end has two tinned wires. Unrolling the whole spool here. For this project we're going to use 1/2 of a strip, or a little over 8 feet. The end with the bare wires will work easily for what we're doing. There's the end. So, folding it in half, we'll find the center. Now this strip can be cut at any point with a white line like this. Periodically they have connected smaller strips together and soldered them. One can easily make strips that were quite a bit smaller, but you'd have to clear the coating off and then solder wires to it. I'm going to cut along this line as a convenient one right near the center. Over the dinette table there are 4 pairs of 18-inch fluorescent bulbs. Each bulb pulls roughly 15 watts. So there's 120 watts of lighting plus what the ballasts pull. This is what they look like with the lights on. I'm going to be replacing one pair with LEDs today. Starting point is to remove the cover. Then the 2 bulbs. Now the cover that's over the ballast. It just pops out. The ballast, I found them connected a lot of different ways. This one appears to be riveted on that end and on that end. That's probably original, never was replaced. So it's going to require cutting off or drilling out the rivets. I'm going to try cutting them off first. Since I'm not going to use these wires, we'll cut them near the connectors. Leaving the connectors in because there's no reason to remove them. We will be using the black and white wires, which are power. Got those there. Now let's see if we can cut this rivet off or not. It's got a washer on it. That popped pretty easily. Let's see how the other end goes. It does not have a washer, so it should just come right off. It does. Just some of the ballasts have been replaced and some of them have not. So now I'll strip these 2 wires. couple of red crimp connectors. Crimp it down tight. Red is positive, black is negative. Which up here, black is positive, white is negative. So we'll connect the red to the black and the black to the white. Do a quick test that we have power in this strip by turning on the lights, and you can see that it's well illuminated. Back off again. The strip has peel-off backing on it. Peel back a ways. Start here and press it down well between each LED. There's enough strip here to go 6 times the length of the fixture. So essentially we're simulating 3 double strip bulbs. At the end, just turn it and start it back the other way. They're quite flexible. This is call it the second bulb, if you like. Once again, we'll come back around. And see, I'm simulating bulbs, so I'm going to leave a little wider gap here. If you want to be precise, you could line these out with a ruler in advance. I don't find that it makes that much difference in the way they look. So, just being a bit arbitrary here. A little extra left over. Just bring it around and keep it up out of the way. Find some spots where it's not tacked down very well. Push it in a little better. Got a few of them here. Okay, wires up, out of the way. Place the cover back in. Okay, now it's in. We'll turn the light on. And it looks like the camera sees this as a very blue light. To the naked eye, it's a nearly pure white, whereas the fluorescent bulbs are quite warm, yellowish in color. The equivalent light, very similar. I would guess that we might have picked up a few lumens, but not a huge number. we will have cut power consumption by more than half. The manufacturer says that these full strips are 24 watts, which would be 12 watts. They probably pull somewhat less than that, but that would be a total of 48 watts for these fixtures that originally had 120 watts. And that's all there is to it.